the last video, or the video, for you to get ready for the test tomorrow. Stuff we've already gone through, so I just want to make sure that you have an understanding of what it is we're doing. And I want to make sure that I'm writing on the right page. Here we go. This is just the problem-solving portion. Everything else should be pretty self-explanatory. We might have a little problem with a couple of things, but we need to get through this. So here we go. What force is required to accelerate a 6-kilogram bowling ball at 2 meters a second square forward? And like I said over and over and over again, force equals mass times acceleration. And here we go. So if I want to know what force is required to accelerate this object, I would just multiply my 6 kg times 2 meters a second squared, and the force required would be 12 kilogram meters a second squared. But this is just the units that go into force. We just call it 12 newtons, right? Newton is the unit for force. There you go. The next one, what is the mass of a cat that weighs 30 newtons? Well, weight, we know, is a force measure because it's listed in newtons. And again, we can say if F equals ma, then we want to know what the mass of the cat is. So m would equal the force, or the weight of the cat, divided by the acceleration. Well, the acceleration in this instance is gravity. It's your weight upon the earth, or the cat's weight upon the earth. So we would just write it out as that the mass is equal to 30 newtons divided by 9.8 meters a second squared, and it's approximately just a little over 10 kilograms, right? And I'm not going to do the math for you because I have to, I don't have a calculator right next to me. Actually, I do. Give me 1 second while I pull one out. Here we go. And let's see. 30 divided by 9.8. I wish I could pull one up there. Sorry, I said 10. I was using 10 for gravity. 3.06, just over 3. Yeah, you could have corrected me all that time. Oops. So it's equal to 3.06. So just about 3 kilograms, 3.06 kilograms. That's the answer. How large is the tension in a rope supporting a 4 2/10 kilogram bucket? Well, this goes back to the force. Tension is a force on a rope, right? So the force of tension is equal to the mass times the acceleration due to gravity. Therefore, it's 4 2/10 kilograms, and we multiply it by 9 8/10 meters a second squared. And let's see, 4.2 times 9.8, and we've got approximately, well, we've got 41 16/10 newtons of tension. And last but not least, I'm going to use the really bright color I have here in front of me. A net force of 125 newtons upward acts on an object. Find the single force that will produce equilibrium. Well, we've got one force pointing upward at 125. How do we get a net force of 0? Well, we have to have a force pulling downward with the same amount. 125 newtons going down. So this one's up, and this one would be down. Sound good? Great. So we'll move on to the next one. I'll put that up and I'll hide this. All right, now we've got that rocket problem. We went through the rocket problem really quick in class. I want to find out. I have a rocket and its weight. Its weight is equal to, what is that, 20 million newtons, or 2.0 times 10 to the 7th newtons. And then the force upward, or the thrust, is 2.5 times 10 to the 7th newtons. I don't know why the book wrote this way. I don't know if I can change it. I'll see if I can change it in the program itself. It's kind of a trick to show you that these numbers, they're basically the same. There's just a difference of 5 million newtons. It's kind of rude if you ask me, so I'm going to try and change it so you have your 10 to the 7ths that are the same. And the first thing we want to do is find the mass of the rocket. And so what we do is we take the mass is going to be equal to the weight, and I'm just going to call it the weight, divided by gravity. And so 2.0 times 10 to the 7th. So if I move this over 7 places, 1, 2, 3, 4, 5, 6, 7, and add some zeros in, I want to show you what it looks like. It's going to be a lot easier to do this on your calculator than, it doesn't have scientific notation on your calculator. So if I use a different color for my commas, you're going to see that I have 20 million. 20 million newtons, right? And that's a lot easier to put into a calculator and then divide by gravity, which is, and I'm going to keep the same color just so I don't hold you up any longer than we have to, meters a second squared. So if I put in 20 million, which is just basically a 2 and 7 zeros, 1, 2, 3, 4, 5, 6, 7, and I divide by 9.8, I get, let's see, what is that? A little over 2 million, and we're going to go ahead and round it. It's going to make our lives a lot easier. I get, and I'm going to write it down here so we can see it. So I'm going to just move it down here. There's a little arrow pointing you that way. I'm going to say it's 2.0 times 10 to the 6th kilograms. Right, I've rounded off. There's extra weight here. There's extra mass here, but I'm going to make your lives easy, and that is a good number. So I'm going to probably leave the mass just about the same so we can use it. Mass equals that. And then what's the acceleration at liftoff? And the fun part about this is you have to talk about the net force, right? And so acceleration is equal to the net force, F net, divided by the mass, okay? And so I know the mass, and I'm going to go ahead and write that right now. The mass is, it's basically 2 million, so I'm going to write out 2 million. I'm just going to abbreviate it, 2 mil. Let's say 2 million. What the hell? And then I'm going to talk about these two numbers up here. Let's use a different color so I can underline them. This is the thrust. Remember the thrust. And then this over here, this is the weight. And the weight, okay? So basically what I'm going to do is I'm going to take my weight. I'm going to subtract that from the thrust. So I'm going to say 25 million minus that 20 million, because that's its weight, its force, and it's trying to push down. And the thrust is greater, right? It's 5 million greater. And that's the best part, because I want to make it as easy as possible for you guys to understand this. You have a difference of, and I'm going to say it, the difference is 5 million, right? Because 25 minus 20 is 5. So 5 million divided by 2 million. And of course, you know, these are newtons up here, and these are kilograms here. And when you divide out the kilograms from here, you get meters a second squared. You get that acceleration. And it's really just 2.5 meters a second squared. And I promise you, I am going to change the numbers, but it's going to be just about this simple. It may be 3 meters a second. It may be 1.5 meters a second. It may be 5 meters a second squared. I don't know. I'll get to that when I get to it. But I just want you to realize that it's a lot easier than it looks. These numbers in scientific notation, like there's this trick, you know, they're trying to trick you with that because there's a 10 to the 6th and this is 10 to the 7th. You know, this is a 2-digit number. So this really isn't scientific notation. I don't know why they wrote it like this unless they just plain wanted to trick you. So I apologize for that. Good luck tomorrow. Those are the two big problems or set of problems on the page. I'm not going to give you any more. There's more complex stuff that it's so uninteresting. Maybe one more problem that you can try and figure out on your own, but not a big deal. Thank you for your time. You guys did great.